Hello YouTubers, this is the Noobifier. Today we're going off the rails a bit. I'm going to briefly explore the subject that's very close to my heart: coordinates. I feel that we take it for granted how easy it is to use them on Earth. We were recently told that there was a big push to define a coordinate system for Star Citizen, and the logical stance would be just do it. Just get it done. On a two-dimensional surface, navigation can be done with an origin, bearing, and a distance. Most of us agree that the Earth isn't flat, so to be more accurate, originally we relied on what's called a surface datum. This datum is a virtual surface that all points on the object were measured by. On Earth, we've selected mean sea level as our surface. It isn't a perfect sphere because of its rotation, but it's expressed with simple math. Based on the datum, we can easily define locations in 3 dimensions. We're so familiar with it because of Earth that it's actually quite easy to define a coordinate system for other planets or moons. Step 1 for Star Citizen would be to define an origin and datum for each planet or moon. And then using a projection, we'd cut it up into a usable grid. Once that was done, I could tell you that New York was 40 degrees 34 minutes north and 70 degrees 56 minutes west. But obviously, space complicates everything because everything's moving. So what would we choose as an origin? If you were on the moon and I gave you the location in New York, unless you knew where Earth was in relation to your position, that information wouldn't help at all. Obviously, if Earth was visible, you could fly towards it and that would be the solution. If Earth was very far away and you didn't know which point of light was Earth, then you'd need something other than sight. Space for now is accepted as 3 dimensions, which is XYZ. So in this scenario, let's choose the moon as our origin. We could express its relation to Earth as a set of coordinates and we'd be fine. Not so fast. If it was that easy, CIG would have been finished. The moon orbits the Earth orbits the sun is moving, and the universe is expanding at 67 kilometers per second. Everything is moving relative to itself, and Star Citizen intends to simulate planetary rotation and dynamic orbits. If you were in a moving car, the only way to tell me where you were would be to give me the exact point that you were at that time, or you could say that I'll be somewhere in an hour. My goal today isn't to fix the problem or invent a coordinate system for CIG. My goal is actually to demonstrate why it's a lot more complex and perhaps why it's not implemented yet. We can't just set the center of mass as the origin. The simplest way to describe this technical hurdle would be a sniper shooting a moving target. By the time the bullet reaches the target, it won't be at the same place and the sniper might miss. Factoring in time of flight and the distance means that the sniper could compensate by leading the target. Using a known orbit, a scientist would perform a complex calculation to choose the best window to send an astronaut. Just like leading the target, the exact time of flight would need to be anticipated, so he would know how much to lead the rocket's path so they would intersect in 3.1 days. Defining coordinates in space is difficult because everything is moving. Knowing its XYZ location won't actually offer a complete solution. It's dynamic. All moving objects in space would have an orbit that can be represented as a mathematical expression. Knowing its orbit means that you can calculate where the object will be at any given time and tell you where to fly. As far as we know, this issue is quite simplified for Star Citizen. Our simulated universe will not be expanding and the galaxies aren't moving. The only variables might be that the planets orbit and the planets rotate, but that's also coming later. Thanks very much for spending your time with me. Please ask me any questions or offer your thoughts in the comment section. I love making videos like this. Fly safe, and I'll see you in the verse.